right, check this one out. What we're going to do is the same strategy we did on the last one, but it's going to turn out a little bit differently. You may want to try this one on your own. I do recommend looking at the graph, though, but you're going to need to do the algebra as well. So didn't leave myself much room. We're going to bring the work down here and factor, we're using grouping 2x squared and then x plus 3 minus 50 and then x plus 3. And there's your numerator. We'll keep driving that train. So we have 2x squared minus 50 and then x plus 3. And I'm going to skip a step here. If I factored out a 2, that would leave me with x squared minus 25, which is x plus 5 and x minus 5. And then we'll have x plus 3 right there. Okay, there's your numerator, all nice and done until we cancel. So x squared factors out of those, and that leaves me with x minus 5. And then 16 factors out of those. That leaves me with x minus 5, lucky us. X squared minus 16, you can see where this is going. So x plus 4, x minus 4, and then x minus 5. And we're ready to cancel some stuff out. And that's all that cancels. There's going to be one hole on this one, but 2 vertical asymptotes. That's why we're doing this one. It looks a lot like the last one, but this one's a little bit different. Okay, x plus 4, x minus 4, there it is. And we are ready to jump in and find everything else that we need to find. So we have, fun times, x-intercepts, plural, x-intercepts. Y-intercept, you'll only have one of those, otherwise it's not a function. You have one hole. We have a vertical asymptote times 2 vertical asymptotes, and you have a horizontal asymptote. That horizontal asymptote, we'll start there, is going to be at 2 over 1. So y equals 2 over 1. There we go. Let's draw a horizontal line at y equals 2. Okay, vertical asymptotes. That's going to occur where your denominator equals 0. I don't feel like writing it anymore. I'm done with vertical asymptotes. Now, x plus 4 equals 0, so x equals negative 4. And also, x minus 4 equals 0, so x equals positive 4. You could do the plus or minus thing. I'm not. Totally okay if you do. 1, 2, 3, 4. Technically, it is 2 separate equations. 1, 2, 3, 4. There's those. Okay. 2 vertical asymptotes. What are we going to do with that? Don't know. We'll figure it out. The hole occurs at x equals 5. We'll go ahead and start there. Skipping some steps. That's the thing you canceled out. Excuse me. And we're going to plug a 5 in here. It's going to be a sloppy one, but that's okay. Plug in a 5 gives you a 10. Plug in a 5 gives you an 8. Plug in a 5 gives you a 9. Plug in a 5 gives you a 1. So we're going to keep going with that. Let's see. 20 times 8 is 20 times 8, 160 divided by 9. 160 divided by 9 does not reduce. 160 divided by 9. All right, something about that feels off. I'm going to double check it in a minute, but let's keep moving for now. Y-intercept is, let's do the shortcut. All your x's are gone. I'm left with 150 over 80. Just do it. So y equals negative 150 over 80, and that's going to give me negative 15/8. X-intercepts, plural, is where your numerator equals 0. That's at negative 5 and at, negative 3. Okay, we got a mess. Let's start graphing. Negative 5, boom. Negative 3, boom. Negative 15 over 8, that's almost negative 2. All right, I said I would double check that one, and I really want to, so I'm about to. And it's going to happen right now. Off camera, you're not seeing what's going on, too. Yeah, I'll let you see. I'll give you a clue into it. By the way, I've already typed the original function. This is what the graph, looks like. It takes forever, doesn't it? So we're going to graph that in just a minute. And it's going to be a weird one because you have 2 vertical asymptotes. And then there's this crazy thing that happens up here as well. Notice the slope of that. I find that interesting. And our points are in the right place. I'm just going to double check and make sure that the hole is in the right place. But it's still going to go like way, way yonder off. So I'm going to type the reduced form in there, which should look the same in the graph with the exception of a couple points, x plus 3. And then we're going to divide by x plus 4. And whoops, any parentheses around that. And actually, since these are two separate factors, I'm also going to divide by x minus 4. Totally works that way. You can do it. And if I go to the graph, it's going to be the exact same graph. However, if I go to the table, you can do this in Desmos. If I go to the table, I could type a 5. I'll get an error on the first one because that had the stuff that should have canceled. And then on this one, I have 17.778, which is, please be 160 over 9. Yeah, we're good. Okay, it's right. So the whole is way off the graph. Way, way, way off the graph. But we're going to draw it. I'm going to draw what we can. So let's go to the graph. And it's actually graphing the second one as well, including the whole. So it does this. Whoa! Got way too close to the asymptote there. Didn't touch it. Maybe I did. I don't know. And this is going to come down. We do cross the horizontal asymptote here, by the way. Just saying. Sometimes you have to. And the lights go out. We had to cross the horizontal asymptote because we had more than one vertical based on the shape of this thing. And then this one is truly going to level off at the horizontal asymptote on this end. All right, talk discontinuities, and then we'll be done with this one. All right, we have a removable discontinuity at x equals 5. We have non-removable discos at two vertical asymptotes, -4 and +4. We'll call it x plus or minus 4.